Welcome everybody. Thanks for joining. Looks like we've got 49 people online right now. We'll see how that evolves. This is the session on machine-readable descriptors for heterogeneous tabular data. Nice, catchy title there. I'm assuming everybody can still see my screen and showing now the agenda slide number 2. I'll show a few slides for 10 minutes, maybe fewer. Just to kind of get things going. And then we have 3 guest speakers who I really appreciate. Paolo Starace from Cyan Lab in Rome, I believe. Bob Simons from NOAA Fisheries in Monterey, or near Pacific Grove, I guess, California. And then Tran Nguyen from UC Davis, each speaking on 3 different ways to do machine-readable descriptors of tabular data. So each of them will have about 15 minutes to give a little briefing about what they've used with some of the, how they use one of these technologies. And then we'll go into a breakout discussion. I think there's probably going to be too many for a single group discussion. So break into probably 4 rooms for maybe 20 minutes max, and then come back just to hear a short summary of key points from some of those rooms. In the Kiko chat window, you should be able to see the collaborative notes document. There's a link here, but I guess you can't click on it yourself. But if you can't get to that and you want to, let us know. Everybody's welcome to put any notes, jot any thoughts down in that document as we go. In terms of organizers and speakers who are here, so I'm Jeff de la Beaujardière, Director of the Information Systems Division at NCAR. Bridget Thrasher is the NCAR Data Stewardship Coordinator, and Eric Nienhaus is a section head of SAGE, Software Applications and Gateway Engineering. And also not listed here, but we drafted at the last minute Nathan Hook, who's in Eric's group, to help moderate one of the breakout sessions. So Nathan, thank you for that. And then I mentioned the speakers previously, Paolo was a solution architect and co-founder of Cyan Lab, Bob Simons, IT specialist at NOAA Fisheries, and Tran Nguyen, assistant professor of environmental chemistry at UC Davis. And feel free when you give your talks to give any more bio info about yourselves. So I just wanted to summarize the problem, at least as I see it. One problem being a typo in my title, darn, okay, too bad. There are many data sets that are small and tabular in nature. For example, in this one, this would be a fake in situ measurement of temperature. So you might have a time, a longitude, a latitude, and then a temperature value. And this particular one, each of those is structured in a certain way, and the columns are named in a certain way. And you could imagine getting this as just a comma separated value, plain text file, or tab separated or something. Very easy for a human to interpret typically. So that's good. Humans can read these and do this. But then somebody else may be measuring, let's say, temperature, and it's just different enough to be incompatible, right? The date might be formatted differently, and it might be, the column names might be different. The units of measure of temperature might be different. The way they've structured the position may be different. Any number of differences that can make it difficult to, say, combine data from multiple sources. So this is, in my view, unfortunate. So, the tabular data is heterogeneous, as it says in the section title. Some things are compatible, right? It's either ASCII or UTF plain text, commas or something to separate them. That's great, but different column labels, different representations of time and position, different units for the same quantity, no additional metadata about the structure of the data. Or metadata that is not machine readable, like there could be a readme.txt file. There could be a machine readable ISO metadata record, but that doesn't normally say, hey, these are exactly my column names, the order of the columns, et cetera, et cetera. So there are some interoperability issues here. So the impact is it's difficult to combine or analyze the same type of data from multiple sources without human intervention or some kind of custom code that reads each one. So I'm wondering, can we have an agreement on machine readable descriptors? Could be an external file, or could be something perhaps inserted at the start of the file that would tell you, what the column order is, what the vocabulary is used for each column name, what the units of measure, any kind of metadata we want to put about these text files. So they may stay heterogeneous as the source files, but there's a standard way to essentially describe the file and have software able to read them without a human intervention. We've looked at a couple of options for this, and this session was of interest. We wanted to have this session to be able to discuss some of these options and other ones. We found a World Wide Web Consortium thing called CSV on the web, which uses JSON, and Paolo will talk about that. CSVY uses YAML, and Tran's Icarus project that Eric's group is involved in uses that. Bob's group has a piece of software called Erdap, and they have a thing called datasets.xml, which is an XML description. The British Atmospheric Data Center also uses a CSV approach, some additional lines of CSV at the start of the file. I'm not sure whether NCML, which is normally used to describe netcdf files, could be also used for CSV plain text files, and there are probably others that we don't know about. So I don't know, which ones of these are good. Are there some that are in wider use or not? Questions like that arise. At NCAR, we do have a specific motivation, which is this project that we got some funding for called Geoscience Data Exchange. So we've been asked to serve as a long-term archive for data from a set of facilities, the NSF community instruments and facilities. And we're actually still waiting to hear which facilities will have been selected as part of the solicitation, but they have been told that once they get funded and start gathering data, they're supposed to send it to us for archiving. We've been told there'll be about 10 facilities with maybe 100 terabytes of data total. It's not a large volume, but we believe at least some of them will be giving us tabular data like what we've just been discussed. And we may have limited power to impose uniform formats. Like we can't necessarily tell them, oh, everybody format your data exactly this way, which that sort of uniformity would mean we don't necessarily need a separate descriptor for it. But we suspect that we're going to have a lot of heterogeneous data, and it would be very good to be able to have a common description of them that we can provide even if they don't provide it themselves. In this Geoscience Data Exchange, at minimum, we'll let people discover the data that we have and download or obtain the data in an open data way. Minimum you could download. Depending on the nature of the data, we may be able to offer subset services. And it'd be great if we could offer some kind of unified view of the entire body of data from these facilities. For example, every facility that measures temperature, I want to see all these temperature measurements. We didn't promise this in the proposal because we don't know if it's possible, but to make it possible, I believe we would need some kind of machine-readable descriptor. So that's our particular motivation in having this session. We started looking at what are the attributes of some of these approaches, the CSVW, the datasets.xml, CSV YAML, the British Atmospheric Data Center CSV, there are others. Things like what format do they use? So JSON, XML, YAML, plain CSV, something else. Is it inline or sidecar? So by that we mean, is it a separate file that describes the CSV file, or is it lines of additional CSV or YAML that you put at the top of the CSV file, and then you have the data values below? Who's the publisher? World Wide Web Consortium, NOAA, csvy.org, BADC, there may be others. And then, what kind of functionality do they support? Can we use them with the files as submitted? For example, the sidecar ones, you'd think, okay, I can use, somebody can give me a file for archiving, and then I can write a separate sidecar file that describes it, and I'm not touching what the person gave me, what the data center gave me. Others, if I have to insert text at the beginning, then of course I'm changing the data that was given to me. Do they have some kind of way of describing useful things like date and time and geolocation and units and standard variable names? So, right now these checkboxes are blanks. I have some thoughts on some of those, but just to show you some of the kinds of things we've been thinking of would be useful to have in these various descriptors. So that's my intro. Next, we're going to have 3 talks, Paolo, Bob, and Tran on the following 3 topics. I'm going to let you folks each share your screen in turn if you have any problems. Well, Paolo, I do have your slides as backup. Bob and Tran, I don't. So hopefully everything will go well on that end. So I'm going to stop sharing, and I'm going to turn it over to you, Paolo, to share your screen.
Okay, Jeff. let's start the screen sharing.
And Lindsay, maybe I asked you while Paula is starting, should we turn off our videos if we're not speaking just to conserve bandwidth? Is that the practice we've been using?
So far it's been pretty good, so I don't think it's necessary. Yeah.
Okay, so
okay.
People do what they want.
Okay, slides. Should be that one. Okay, can you see the slide?
Yes, we can.
Yeah. Okay, I will try to put it on full screen. Oh, no. Okay. Okay, thanks, Jeff, for that time. I'm just to shortly introduce myself. I'm Paolo Starace. I'm a solution architect and co-founder at ShamLab. ShamLab is a software and data management company based in Rome. And we mainly, at ShamLab, we mainly deal with data integration management projects for public and private sector. During last year, our involvement in Open Data Initiative is mainly focused on a partnership we signed with Open Data Soft, that is a French software vendor of software as a service platform for open data publishing and management. So I'm here today to talk about CSVW, as Jeff said, and in detail about the implementation we did in 2016 for Italian Ministry of Transportation in the context of the Open Data Initiative they implemented together together with ShamLab using CCAN. So just as a note, in agreement with Jeff, we decided the talk will address not only the transportation use case, but also the CSVW approach in general, just to provide to all of you an overview of the result of the work of the Web Consortium working group on CSVW. So I was speaking using the past since the working group is now closed. It closed actually in 2016, and the activity around CSV and tabular data in general has been taken up by the CSV on the web working group. So, as you know, as we said, few minutes ago, the one from the Web Consortium is not the only proposal for describing the content of the tabular data on the web, and several other approaches are available. And this is the short list I took from the session introduction. So after my talk, there will be Bob and Tran that will talk about two other approaches, and I don't want to anticipate anything about, because for sure they are more authoritative, let's say, for speaking about. So my experience is mainly on the Web Consortium approach and the table schema one. Both are JSON based and are very similar. On that, it is enough to observe that the Open Knowledge Foundation is one of the authors of the Web Consortium documents, and as well is the main partner of the frictionless data initiative that is the mother of the table schema proposal. Okay, so this slide is for a short introduction about the CSV on the web working group. As I said, the working group is no longer active. The work was completed on February 2016, and the result was 7 documents that include 4 recommendations. That is the main documentation about CSV on the CSVW. The first recommendation describe in details the tabular data and the metadata together. And so how to build, how to model the data into table and how to annotate the content of the table as well. And the second one describe in detail all the rules to be followed for publishing. And the last two documents are about generating JSON from tabular data and generating RDF from tabular data. So the main point here is that tabular data CSV that is annotated using that format can be easily translated into JSON LD or RDF, so into a linked format. Okay, so okay, sorry. So I will. I want to speak to talk about best practice very shortly, because we know that tabular data files are heterogeneous, and the discussion here is still open. There are no mandatory standard. There are some RFC about. And there are no rules, but just a convention about the naming, the ordering of columns, and how to use the units for measure into the columns and so on. So the CSVW proposal tried to address the problem, advising among all the rules, but they are the first to say that this is just a guidance. And this is the short extract from the RFC number 4180. That is the single document we have about structuring CSV. And the Web Consortium is the first to say that some of the rules they advise clash with these documents. And as you can see, the document is just 6 pages, so it is not a very detailed standard as we are used to see for other contexts. And just to give you an example, one of the rules they advise to break is about the line handling of the CSV. So the RFC advised to use the carriage return line feed, while the Web Consortium say that line feed is enough, considering most of the CSV are processed using Unix platforms. So keeping aside the rules about structuring the tabular data itself, I would like to pass to the annotation, so the metadata. So here we have a short example, a small example. It is a few columns CSV with just 2 rows. We can start easily creating a basic annotation, as you can see on the bottom. We are starting about the type of the document, that is a table. We have a link to the resource, and this is really important because we will see the data are connected to the metadata in a double way. So the metadata has the information about the data, and the data provide information about the location of the metadata. And here we have just few information about the schema that actually are adding nothing about the info we can infer from the file itself. So they are just the titles of the columns. Here we can say that this is one of the positive aspects of this approach that maybe is shared with the other approach, but it's something I'd like to mention, that we can start with annotating just few details without being obliged to fill a huge amount of information. So you can start from the base and then add it later on, add the other information later on. Then moving to the next step, we can start naming the columns, as you can see, and giving a title and naming the column in a more machine-readable way. So you can see the name is lowercase now, and then we are adding a title that is human-readable, and some information about data types and format. So you can specify the data type as a standard one, like the string, but you can specify a more complex one, like the date. Then we can fill more detailed information, naming the file on top, adding a description, tags, information about the publisher, the license, the modification date. And as you can see here, we are also introducing namespaces. So we need on top to import the context, specifying how the namespacing are used. So here we are using dcat and Dublin core, and the context is the content that I'm using in this example is the one provided by the web consortium that is named CSVW and already includes most of the relevant namespaces, but of course you can add your own. And then at the end, we have another important attributes, that is the primary key and the about URL. The primary key identify the column we are using as a primary key in the file, as we are usually doing for relational database. And the about URL is the rule to build the URI to identify each row. So specifying the about URL is very relevant in a linked context because you can start linking your tabular data to other linked data. Okay, last step is about parsing, processing and parsing the data we annotated. And this is really interesting because it's the other side of the double-way linking. So we have seen in the metadata, we link the file that belong to the metadata, and the web consortium provide a way to link the file itself to the metadata one. And this is done without touching the content of the file. So while you are downloading the CSV from the web, you can look into the headers of the response. And as you can see, you should find a link header specifying the location of the metadata JSON file. Otherwise, you can start looking for well-known locations that are the ones I put on top of, on the bottom of the slide. And the last attempt is to embed the metadata into the CSV file, but this is something I actually don't advise. I know that, for example, the CSV Y is based on front matter, so it means that we need to put the metadata on top of the file. But I don't like to touch the content of the file, especially because there are RFC advice to use the header of the column as a first line. So last step, sorry, this is last step. Last step is converting, and as I said, we have the ability to convert, and some rules are provided in the documentation to convert the content of tabular data annotated using CSVW approach into JSON LD and RDF. And the conversion process, of course, relies on an external processor. The one I linked here is implemented by Greg Kellogg, that is one of the authors of the CSVW. But you can do the same for JSON LD, and some guidance are provided about, and you can use some open source projects, or you can write your own parser. So just let me close talking about the transportation data use case. This was a project we did in 2016 as a part of our involvement in open government project for the ministry. And we were in charge to implement the data portal, the open data portal, and the choice was using CCAN. And the setup, as you can see, is a classic CCAN with a custom template applied, reflecting the user interface guidelines of the Italian Agency for Digital Innovation. Currently, they have 84 datasets published, and they are huge datasets, so the number is not relevant in this case. Just 25 have CSVW metadata applied. And the nature of the annotated dataset is mainly related to the content. So, I mean, they started annotating the more relevant and maybe the easiest datasets. And what you can find on the portal is annotation about harbors, airports, goods movement, and works, and so on. So if possible, I would like to move to the portal to show you the annotation live. Okay, I need to filter for a JSON dataset. So this means a dataset that contains a JSON resource. And I can show you that one, for example, that is the airport. I'm sorry, the website is in Italian, but I will try to explain what I'm doing. As you can see, we have two resources. The one is the CSV of the airports, and the other is the metadata. So the CSV of the airports is a standard CSV. So you have an ID and an airport name, and so on. And then we have the metadata file. So the metadata file is the same I shown to you before. So we have the contents, we have tables because we can annotate multiple CSV on the same metadata files. And then we have the primary key defined, the about URL. So you can refer to an Italian airport using that URI. Certified airports, and then the ID of the airport, and then so on. You have the description, data type, and so on. So I would like to actually I cannot show to you because I don't have a terminal right now, but if you download the CSV, you can see in the header there is a link attribute that points to the metadata file. And okay, sorry, going back to the slides. Oh, sorry, I lost the slides. Give me just 1 minute, sorry. I'm going to conclude. Okay, I'm back.
Yes, we see them again.
Yeah, okay, sorry. Oh, okay. So, well, just to close, I'd like to answer the question that Jeff asked to me while discussing about the conference. That was about if I had to go back in time to make the decision whether to use CSVW or not again, would you still make the same decision? And the answer is yes for me, because I found it very useful to link tabular data, simple tabular data. So something that was already present into the infrastructure of the ministry. And another reason is that it was really easy to integrate that solution into the pre-existing CCAN instance, because it was enough to customize the controller of the responsible for the dataset, just to customize the controller to return the information about the metadata itself. So it was a really positive experience for me. It was a really positive experience for me using CSVW in a real context like the one at the Italian Ministry of Transportation.
Great. Well, Paolo, thank you so much for this this overview. I think we're going to hold questions until the discussion phase or breakout phase, and move on to the second talk, if that's okay. And Paolo, just confirm, are you able to stay? I know it's late for you. Are you?
Yeah, I can stay, Jeff, no problem.
Okay, thank you so much. We have a nice Italian espresso to keep awake. So I think, Bob, you are going to be the next speaker, so if you can share. Yep, looks like we see it.
Good. Okay, my name is Bob Simons. I work for NOAA Fisheries in Monterey, California. I'm going to talk about using Erdap's datasets XML as a file description system. Actually, I'll also be talking about using Erdap as the data distribution system related to this. And you'll see I started with just this description before Jeff added the data distribution aspect, but you'll see I will talk about that in any case. So. So for the goal here, Jeff described it as describing a lot of different heterogeneous CSV files without changing them so that we can archive the files. That sounds great, but when I hear the word archiving, I always think of the final warehouse scene from Raiders of the Lost Ark and think that's where the data will go, never to be seen again. So I also want to add this third goal, which is providing a way to distribute the data. And conveniently, when we collect the metadata as part of describing the files, that can also be used to help users understand the data. And this is in the spirit of the FAIR data principles: findable, accessible, interoperable, and reusable. So why are those hard goals? Well, as Jeff pointed out, CSV files have no global metadata, the creator, contact, title, summary, license history, provenance, things like that. They have no variable metadata that would describe the data type, the units, a more lengthy name, a standard name, the precision, other information about each variable. And CSV files are very diverse. They have different separators, different character sets, different date, time representations, and sometimes they have header lines or comment lines either at the top or interspersed throughout the file. And sometimes vital information is in the file names. A lot of the data sets I work with have collections of files making up the data set, and some useful piece of information is only in the file name. And sometimes the data, as I said, is in multiple, even millions of files. So we need to aggregate them. So we need a way to describe these files and ideally software to read these files without changing the source files. So what is a solution? The solution I'm putting forward is Erdap's datasets XML. So what is Erdap and what is datasets XML? Erdap is a data server. It is reusable, free, and open source software. It has been installed at more than 90 organizations in at least 14 countries, and it's on NOAA's list of recommended data servers. This is the Erdap homepage, which has a description of Erdap on the left and several ways to search for data sets of interest on the right. If I enter SST in the search box, I get a list of relevant data sets with the most relevant at the top. The data links on the left lead to an OpenDAP style data access form so that you can request a subset of the data. The graph links lead to a simple web page for making customized graphs from the data. The files links lead to a virtual file directory so that you can download the individual data files, etc. Erdap treats data sets as either gridded data sets like satellite data or global model data, or as tabular data sets. So for CSV files, obviously these are tabular data sets. If I click on the data link for a tabular data set, I see this data access form, so I can request a subset of a tabular data set. A unique feature of Erdap is that I can request the data in any of about 25 different file formats, which Erdap generates on the fly. And you'll notice that Erdap allows you to constrain any of the variables in the data set when you're specifying a subset of the data set. If I had clicked on the files link, we would have seen a virtual directory of the source files. So zooming out, Erdap is designed to be a middleman data server. That is, it can read data from a variety of sources, including local CSV files, a local database, or a remote data server, and offer that data to the user with full metadata in a very standardized way, regardless of the source of the data. So it does what this session seeks to do, deal with diverse sources of data, including CSV files, so they can be read, processed, and so they can be found by users and the data used. How does Erdap know how to read data from diverse data sources? Well, it has this large file which contains information about each data set called datasets XML. And basically, it specifies the type of the data source and how to read that data. It's a functional system. And by functional, along the lines of what Jeff is saying, machine readable, I just mean that it's a specification for a way to describe what is in the data file or some other data source, and specifically that Erdap, a piece of software, actually uses that description to read the data from the source files. So if there's an error in this chunk of XML, then the data won't appear correctly in Erdap. So it's easy to see if a chunk of XML is incorrect, is correct, or is in some way incorrect. I think this is a very useful attribute. To err is human, but if our mistakes are obvious, then we can find and correct them. And finally, the datasets XML is as simple as possible. It isn't complex, it is a deep hierarchy, and it isn't hard to read. So I'm going to show you the chunk of XML for a data set and describe it in the first section. The data set's XML has three main parts. This first part describes how to read the file. The data set tag at the top has a type parameter, in this case, a table from ASCII files, indicating that it's a tabular data set from ASCII files, but there are many other types. This tells Erdap what chunk of code to use to read the data from this type of data set and limits the tags that can appear in this first section. The file dir, file directory, can be recursive, and you can specify a file name regular expression, which specifies all of those to specify a group of files to be included in the data set. Char set specifies the character set, so in this case is ISO 8859-1. Column separator specifies the separator, often a comma. Skip header to regis, regular expression, allows you to specify a regular expression which identifies the last line of the header, or you can just leave this blank if there is no header. And similarly, you can specify skipped lines regular expression, which lets you say that, in this case, any line which starts with a hash and is followed by any other characters is to be treated as simply a comment line that should be skipped. There's also a column names row, just says that in this case that the column names are on the first row of the file, and first data row indicates that the data in this file starts on the second row of the file. The ISO 19115 file specifies the location of an external ISO 19115 file that Erdap will make available to users. And if you don't specify this, and the data set has latitude and longitude values, Erdap will make an ISO 19115 file based on the information in the data set's metadata. The second part of the chunk of XML specifies the global attributes for the data set. Erdap is partly tied to the CF, climate and forecast, and ACDD metadata conventions, but all that really means is that there are a few required tags, notably CDM data type, which specifies the geometry, in this case a time series, but it could also be a trajectory or a profile or other types. The conventions specify the metadata conventions which are in use in this file and for this set of metadata. Info URL specifies an external URL with information about the data sets. Institution, license, summary, and title are also required in Erdap. You can add any other attributes that you want from CF, ACDD, other conventions, or custom attributes. It's up to you. Given this and other information, Erdap can generate an ISO 19115 document, which is way easier than generating that document by hand. And the third part is a small section for each of the data variables, most of which come from a column in the file. So here's the longitude variable. Erdap has the idea that there's a source name, which is sometimes cryptic in these source files, like lon is understandable, but often cryptic for other variables. And so you can specify a variable name that users will see in Erdap, in this case longitude. The data type defines the data type of the variable, for example, a float or the different integer or unsigned integer data types, or a string. The add attributes section lets you specify additional metadata for each of the variables. If the variables had units, they would be identified here. Erdap uses the UD units standard, so these are from a specific vocabulary. But of course you can add, and I think there will be some examples below, lots of other metadata attributes for each of the variables. For variables with time data, the values in the file can be strings, in the source file can be strings or numbers. If they are strings, as they are here, you must specify a format using the Java notation for string dates and times so that Erdap can correctly interpret the values. If the values are numbers, you must specify a UD units format, for example, seconds since 1970-01-01. So again, so that Erdap can correctly interpret the values. Time values can be formatted in thousands of different ways, and this system allows for all of those different formats to be interpreted correctly. If the unit string is incorrect, it's obvious in Erdap, and you will thus be encouraged to correct it. The system is fundamental to making the file machine readable because it gets the time data into a standardized internal format. Sometimes the date and time values are in separate columns, and Erdap prefers that they be unified into a unified date and time column. Fortunately, Erdap has a scripting system so that you can create variables based on values in one or more of the existing columns. In this case, I've made a unified date and time column from a separate date and time column and parsed it into the time units that Erdap ultimately wants. It could even be considerably more sophisticated than this. Often, CSV file names have a crucial piece of information. Erdap lets you create a new variable by extracting information from the file's name. In this example, 1,500 National Data Buoy Center files are being aggregated to make one data set, and the station names are being extracted from the file names. And the final part of the chunk of XML for each data set is the closing tag or data set. So all in all, the XML is for a data set is simple, straightforward, and easily readable by humans. So I have a long list of advantages for taking this approach. One is that it works, Erdap was designed to work with the source files as they are without modification. XML is a concise description of how to load, read, and interpret the data files. The XML is a simple, human readable, is simple and human readable. If you ever want to convert to another system, it'd be easy to write a converter. The XML is completely defined and documented in the Erdap documentation. There's a tool to facilitate generating the first draft of this chunk of XML called Generate Datasets XML. The native and preferred metadata standards for use in Erdap are CF and ACDD, which is a natural fit for UCAR. Those standards allow you to add or use other attribute names as needed. Once you specify good CF ACDD metadata, Erdap will automatically generate ISO 19155-2/19139 metadata files. This is vastly easier than generating them by hand, although you can if you want, or if you already have them. There's a scripting system to generate new variables based on existing variables. Among other things, this can be used to interpret odd data columns, for example, latitude encoded as degrees, minutes, seconds, and there's a description of the scripting system. Erdap works with a wide variety of CSV files, different separators, headers lines, comment lines. This works with a wide variety of other source file types, JSON files, JSON lines files, columnar ASCII, NCCSV files, NetCDF files. CSV files are just a small part of what Erdap can handle. This can handle aggregation when the data set is comprised of multiple similar data files. And unlike EML, this is a functional tool in the sense that the dataset's XML chunk is used by Erdap to load the dataset, standardize it, so you can see and test that the specification is correct. This is mature. I've been dealing with data files from around the world for 14 years, adding new features to deal with all the variants of source files. For example, I don't think you'll find a better system for dealing with the astonishing variety of date and time formats. Erdap is open source on GitHub, and several others have contributed code. And there's a community that helps support this, and a Google group, again, which helps supports this. And Erdap provides a way to make the data accessible to users, not just describe the files for archiving. So to be honest, here are the disadvantages. It's not based on a standard. so this isn't a W3C or internet standard. And it's tied to one piece of software with one main developer, although it is open source. But this could be easily remedied if some other group wanted to add a developer to work on the project. 5 other people or groups have contributed code to Erdap, but I admit none is a regular contributor. If UCAR or some other group were to assign a few people to work on an archiving project, perhaps they could assign one of them to be a developer to assure continued support of Erdap and specifically to add features that they need, although I suspect almost all of the features you need are already there. And in the classic open source situation, you'll benefit from the contributions of others as Erdap continues to evolve, and will benefit from your contributions. That's it. You can read about Erdap at that URL. You can see the documentation for datasets XML at that URL. Thank you very much. And if you have any questions after this session, you can email me directly at that email address.
Great, Bob, thank you very much. Yeah, we are a little bit past the 15 minutes again, so we'll save questions for the breakout if that's okay. And we'll bring on Tran. Thank you. And let's see, I guess, Bob, you can stop sharing. And Tran, you can bring yours up.
I would if I could. How do I get this screen back? It's gone. There it is. Hold on.
All right. Tran, are you able to share yours? Yes.
Can you see it?
Yes, we do. Thank you very much.
Okay, great. Yeah, thanks for having me. I'm Tran Nguyen. I am an assistant professor of environmental chemistry at UC Davis. And I'm here to talk to you about our use of a CSV YAML or CSVY in our atmospheric chamber research database. So as you can see, I'm not a data professional, and I'm also not here to convince anyone to use this specific data format, just to detail how we do it. If you've never seen an atmospheric chamber research facility before, this is what it looks like. This is actually my lab. Generally, there's just some enclosure with some bag inside made to simulate the atmosphere. So this has been going back to the I want to say 50s, since people first started doing smog chamber studies. And there's some really valuable data that got generated in terms of all the kinetic coefficients and what we know about air pollution, some climate change coefficients. And all of that is very valuable. And there's actually no platform to archive these data or make it available for use. So that's why we started our effort here. So our database is called Icarus. What it looks like from the web version. So there's the public facing website where you can do a search for the specific data set that you're interested in, or you can, click show all experiments. And what you will see is that it'll list, right now we have about 376 entries, the experiment name, PI, dates, reaction categories, reactants, and there's actually many more columns if you scroll. And you can filter based on some of the terms you're interested in. Many of these items are actually controlled vocabulary. So especially with the reactants, we use a PubChem database to manage it so that we don't have confusion. Basically, we manage data and we serve as a sharing platform for these atmospheric chamber data, and we sync automatically to Dash. There's also a user data intake portal that is password protected. You can go in, and if you're a data contributor, that's where you fill out your data intake forms and upload the CSV files that will generate the CSVYs. So what is this all for? It's mainly for developers of chemical mechanisms to simulate air quality, climate, and other types of kinetic processes in the atmosphere. Then the main consideration for people using these types of data is generally not even related to format, but if there's enough metadata for them to understand what these data sets and files are telling them, that's the main consideration. I know that there is a version in Europe called Eurochamp. This is the second version of that database. The first version, they uploaded more than 1,000 data sets, 11 of which has ever been downloaded or used. And the reason being is just there wasn't enough description for them to be useful. So we're trying to learn from this, and so has Eurochamp, who now has a new website. So what kind of heterogeneity are we dealing with in our specific discipline? Well, for atmospheric chamber data, we have lots of things that we measure in terms of chemicals, but also reactive radical species, and not just, time profile data. So time on one column and then concentration of ozone, for example, on another, but there's size distribution too. So aerosol sizes, optical properties, so nanometers of wavelengths as the x-axis, functional groups, OH radical oxidation will create many types of functional groups, and sometimes that there's spectral data that describe them. So there's actually a lot of ways this data can look. And so each lab will also have hundreds and hundreds of experiments. There's some labs going back decades that have more than 1,000. And each experiment will have something like anywhere from 1 to 10 or more instrument data sets available. If you saw my chamber, you might be able to see some instruments on the outside poking their sensors in. There's usually a bunch of in situ measurements at the same time. And each experiment is going to have a unique timeline file. That's a CSV that's going to describe exactly what happens when the lights are turned on, etc. So that's very specific. So in total in our database, we have over 100 instruments right now. Some of them are similar, but they're not described exactly the same way. And each one will have something like 1 to 50 data columns. So with all this, we kind of have to figure out how best to manage the complexity, but also to make it intuitive and easy for everyone to use, right? That's the incentive for them to use this, is it should be easy. So I'll talk about why. So why the why after CSV why. And to be honest, I'm not really sure. I'm not really the one who came up with this. It was a developer that used to work on our project, but he has since left to another company. But so all of this, I have to say, I'll tell you as far as I understand the logic behind choosing it. So we chose this format as a way to combine all the metadata that we're collecting from the web entry forms with all the uploaded CSV files that are coming from the instruments and the timeline experiment files. So we chose a format that has good human and machine readability. Also, we wanted it to be compatible with some programming tools, a plus if there are already available like reader scripts that have already been shared, and good compatibility with other data formats in case that there's you need to convert. And also one of our long-term goals is compatibility with the other chamber databases. So we want to be able to convert back and forth. So YAML, you may be familiar, probably more familiar than me, but you're definitely familiar with JSON. It's very similar. So here's one example of JSON that I just pulled off the web. And then what YAML does is very similar. I think that there's just some syntax differences, but you can have these descriptors, and it's very compatible with all the metadata descriptors that we collect. And you have these nice like nesting for different objects and all of their children. They just use some indentation and hyphens. So sometimes we'll have multiple entries that we control, like a reaction category. You might be able to choose oxidation or photolysis or something like that, and then they'll list it. And then we do an inline appending of the CSV to the YAML front matter, and then just choose any arbitrary delimiter group. That's the way that we've chosen to do it. And I'll show you that the main way that people discover the data is through the web format. So here is, if you click on one of the experiments that I showed you from the web search, it'll bring up this experiment right here that has all the metadata, like, you know, the goals and what chamber it's associated with, what experiment set, the summary, the notes, the PIs, their org IDs, then all the reactants, you know, linked to the PubChem database, and then the concentrations. Here are all the instrument data sets and visualizations of that, the timeline, so you can see when things happened, the ID of the data, and then ID of the DOI of the data, and also for all the associated publications, characterizations, and the details of the chamber. So if you did click download, that's when the CSV files are generated, and then that's zipped. So if we did download, we get in the zip file the experiment, associated publications and characterizations. So I just want to give you an example of what these look like. If you click on the experiment folder, you'll get all the data sets in one folder, and then the experiment file. And then if you click on the data set folder, it'll open to have the instrument data sets. And just to be weird, we decided to use a TXT extension, even though it's technically CSVY, just so we know we're gonna get a million questions about it, so we don't wanna deal with it. But if you wanted to double click on these are CSVY based files. So I'll show you an example, okay? The experiment file, so here we actually copy all like the intake values, experiment ID categories, etc. So the chamber information, and all this yellow is YAML. And by the way, it's longer than that. I broke it up. The main goal is not for you to do this manually, of course. We're going to have tools to automatically extract all this information into things like MATLAB or Python. And then the CSV for this file it's a timeline file that gets appended to it. And this is just our little separator here. And then the instrument files, each of the several or maybe even dozens of instrument files kind of look like that, as well as the YAML front matter, and then the separator, and then the CSV instrument data here. And here in the instrument data file, it is actually what you're inputting once and saving into our database is it generates the column headers for you, so that at least for that specific group, there's no way that you would have one day they'll say NOx with a small x, and another day it will say NOx with a big X, you know. So there's some level of uniformity, not as much as we'd like. We got some pushback on making things a little bit too uniform because everyone has such different data that sometimes they want it to be special. So what we did after we started the development is we sent it out to a group of modelers to review and see how we're doing, and see if this type of the way that we're presenting the data and the way that we're making it available is it going to work for them? Because mainly the modelers are our user group, right? So we have about 13 modelers who did an in-depth review using mechanisms like MCM, Gecko-A, Foam, Gamma. And so we asked a few questions. There's a lot of questions, but I'm only going to be showing the responses from the data specific ones. So rate the usability of the individual experiment files. 1 being it's bad, totally bad, and 5 is the best ever. And I think we did pretty good. Most people said 4, so like very good. And some people said excellent. So we're right about 4.2. So the CSV-Y type of format, at least to the modelers, is working out pretty well. So we asked how easy it is to work with the downloaded data files. Is it extremely easy or extremely difficult, being 5? So we got most people saying it was extremely easy. Some people said it's easy, but not extremely easy. There are 2 in the middle here, not easy, not hard. And then there's 1 person that said it was challenging because, and they note that is because there was nothing to read the CSV-Y files to their preferred program. So that's coming. So hopefully we're going to move some of these 3s and 5s over to 1s and 2s. And then do the downloaded files come with enough metadata to use and understand the experiment data? Now, I think that we probably have one of the more descriptive metadata that I've seen, but there are quite a number of people that said it's not enough. But luckily for the majority of people that it is enough. And then there's 1 person that says there was no answer. And when it comes to not being enough metadata, they actually wanted more descriptions of units, which I'm sure you're all aware is very important. So what else could be done to improve the usability of the data files is what we asked. And generally it comes down to clarity. This is the most frequent request: clarity on the measurement units, clarity on the names of the measurement variables. If you're saying M over Z 182, tell them what that means. I think it's a very logical request. And then clarity on what the file format means and is like. So even if you think that the file format is super standard, I don't know that researchers are familiar with any of these file formats. So we're going to provide documentation. That's something we haven't done. And then the data readers to convert to things like MATLAB, Python, IDL, R. And some people wanted us to have Excel worksheets. So from CSV to Excel. And that's definitely doable as well. So we don't want to fight against the workflow. So what we're doing now is working on the documentation, how-to videos. We think it's actually intuitive enough, but we're working on some of the feedback that the modelers gave us. And that's because we gave them no instructions and most of them figured it out. So it has to be intuitive enough, right? So then the best practices now to this is not for the modeling community, but for the data contributor community to standardize our units and at least our reporting of the units. Provide the custom scripts, then enforcing missing data and files, validators for the tabular data, and more data uploaded, that's always good, and then expand our membership. So in closing, I'd like to thank the many people across the United States who are involved in this project, all the researcher collaborators I work with, all the data management collaborators at NCAR, some of whom are running this session. Without them, I really would not know all that I do now, which is less than you, but I still way better than when I started, trust me. And then the programming and development, thanking Jerome Post from UC Davis and project organization, and also funding support from NSF.
Great, thank you very much for that. I'm going to go ahead and share my screen, and we're going to go back to, we're going to do a quick breakout. Each of the speakers went a little beyond the 15 minutes, which is totally fine. I think we had a lot of good information here, but maybe we can have time for still a very quick, let's say 15-minute breakout. Lindsay, can you sort of time that? Now,
Yeah, I got the timer on, and I'll set up the rooms in just a second.
Okay, so people who want to participate, choose one of these rooms. I did room A, would focus on the CSVW. That was the first talk we heard. Room B, datasets XML, second talk. Room C, CSVY, the talk we just heard. And then if you stay in the main room would be, you don't want to talk about any of the above, like, you know, you have another idea, or you don't think we should do this at all, or whatever. So Bridget, Nathan, Eric, and I will each be in one of these rooms as sort of, you know, moderator. We'll try to take notes in the Google Doc, which, let me put that link just very directly in the chat. If I can get back to the Zoom. Oh, I bet the chat disappears though, right? When people go into their breakout rooms.
I believe so, but they'll have another chat. But yeah, set up the rooms for the breakout, and people can self-assign into the rooms. But I can also, if people write in the chat which room they want to go to, I can also help shift people to rooms. But they should be able to choose. You should be able to choose your own room by clicking on the breakout rooms icon at the bottom of the screen, and then choosing A, B, or C.
Okay.
And then again, room D will be just staying in this main room.
Great. So you can choose your rooms, and maybe at least the rapporteur. Make sure you can get to that Google Doc to type in any notes you want to do. And 15 minutes, and we'll come back here for a very quick wrap up. Thanks.
And feel free to just chime in the chat if you can't get a room B. Okay, yeah, great. Anybody who needs me to help add them, but you should be able to add yourself as well.
Sorry, I'm seeing a list of breakout rooms, but how do I get into one of them?
That's a great
The little number to the right, or to the left.
Oh, I
There's a
got
little
it.
number
I got
that
it. I
says-
got it.
All right, I think I've added everybody who's chatted in the chat. But if anybody else is having trouble getting into the room they want to go to.
I mean, I see my name in the group B, but I'm not sure how I can join. It says I'm not joined.
Oh, still not joined. Okay.
It says, yeah, not joined.
Oh yeah, I see. I moved you, and it looks like your name is grayed out, so it's like you're there, but you're not there.
Do I need to leave this meeting to join that group, or it's acting weird? I don't know. One more time.
I don't know. I can try again.
Please
Maybe
do.
you sign back in.
Yeah. I'll leave this meeting and come back.
Okay, great. Thank you. You put the blue number in the breakout room.
Okay, so presumably the people hearing me now, if you can hear me, are the ones who stayed in quote unquote room D. Is that right?
That's right.
All right. And
it looks like we have a decent number of people in each of the other rooms. So.
Okay, that's great. Hey, Sky, long time no see. Great. Okay, so this was the none of the above room, or I have a better idea, or it's stupid to even try this, or so. Any thoughts on this? I'll try to take some notes in that Google Doc in sort of group D, and yeah, go. What does anybody think?
Jeff, one of the questions I'm wondering about is, have you ever heard of ecological metadata language?
Yes, vaguely. EML, right? Isn't that the...
Right, it's EML, and it's got an extensive section in it for dealing with all sorts of comma separated value data. There's a lot in common, but with what you already have. But there's also sort of a huge number of tools out there. There's R packages for dealing with it. It does code generation, so that if it generates the R code and downloads the data for you. There's sort of a bunch of stuff there that could be relevant to you.
Okay,
Yeah.
so we should take a look at that.
I'd like to, this is Margaret. I'd like to echo what John brought up. I work with EML pretty extensively, and basically everything that you were describing that you needed to describe the structure of a text file, EML can do it, to the point that we can take an EML described data resource and generate database insert statements out of it. Or John has written a lot of these there. You can use that metadata to generate code to ingest a data table into an analysis environment. He's done them for MATLAB, SAS, Python, a couple flavors of R. So it's really useful to look at, and when I was kind of looking at these, especially Paolo's talk, he had a lot of really good structural stuff. It looked like everything that's in his JSON file could be generated out of an EML file. So for us, that's great, because if one of these community or one of these evolves to be a community standard, we could easily create it if we had to. We already are creating schema.org metadata for the web already out of EML. The other thing, one other comment I wanted to make though, is in your introduction, you talked about the structure of a text file and also the semantics of the column names. And to us, those are two different things. Being able to describe the structure and read a table into something else, an analysis environment or a database or whatever, is a little different than actually being able to understand it. And it really helps us to split those two issues apart, because they take different skill sets to address them. So actually EML can handle an annotation to an external dictionary for the descriptions of data table columns, which is actually really useful insofar as those exist. That's a problem that we're at now. We've been able to do the structural part for a long time, but the actual semantics of measurements takes a lot more work.
But is still in the same EML file, or they're two separate?
It's in the EML, the way we organize a package in EML uses your sidecar model, where the metadata is separate from the data object. So one of the things that EML doesn't have built in, I wouldn't say it's not good at it, it's not built in, is this sort of the concept of a key, that something in the metadata has to refer to a column of data in a data object. That has to be that's an external feature that you would have to write to assure that you had a connection between a metadata record, which is the sidecar part, and the data object itself. But yes, it's all internal to EML. The semantics is not. The semantics is a link to an external dictionary.
And the EML metadata actually has the instructions for where you get the data. So it gives you the instructions for where to go hunt things down. I have an EML document up in Oxygen if you want me to show you the XML file, but it's the familiar things. It's gonna say, what's the record delimiter, how many lines are there, how many header lines are there, all of that sort of information. And then for each of the attributes, it's going to have potentially lists of codes, if they're particular codes, and their definitions. It's going to have, it's going to tell you what type of number is it. It's going to tell you what the units are, and conceivably what the methods are that were used to generate it. It's something that doesn't leave out a lot. Let's put it that way. So some people wish it left out more.
I'd love to see specific examples, but maybe not now, just in the interest of time, especially if other people, I see 3 hands raised, are thinking, I've got something even better than EML.
Yeah, no, that's fine. I'll paste a link into the chat.
Okay. I don't know the order of hand raising. Tyler, I'm going to call on you first, I guess.
Hi. I was just going to say, I guess to me, as long as you have a standard that can express the things that you need to express, then I think you should just choose something and go with it. You know, I think that the most important thing is to have a standard that you can point to, right? And you can show people so that they know what to expect, right? And as long as, I mean, I think there's a bunch of standards that you could choose. Frictionless.io is another one that I've heard for tabular data. So there's a ton of different standards out there. But as long as it's machine readable and as long as it's a standard, then I think just pick one and go with it. Yeah, just pick one and go with it. As long as it does what you need it to do, then I think you've got 3 great options there. I mean, the Erdap is not a particular standard, but it does have additional functionality as well. But I think you've got a bunch of different options that'll probably meet your need.
I think that's true, but just pick one is hard. You know, I agonize for months, like, oh, I have to replace my cell phone, which one to get? And here it's like, okay, now developers are gonna actually have to start using this stuff. So, but I do appreciate that. You're right, any one of these probably is gonna be satisfactory, so. Yep, Sky, you had your hand raised too?
Yeah, I think Seth had his hand before me, so go ahead, Seth.
Okay. You're muted.
Muted, yep, there we go. So I just want to say, I think one consideration that I didn't really see addressed is what happens when something comes along that has different assumptions about the semantic meaning of, you know, the contents of your file. Like you know, the one that always comes up in climate modeling is we have climate models that have weird calendars, and so people define date specifications as, you know, year, month, day, and things like that. And then you say, yeah, but I need to declare that I have time where leap years don't exist, you know, or what happens if you've got something with lat long data and they say, okay, what's the geoid? And whoever produced the data says, what's a geoid? I don't know what that is. And it turns out that they've done something where they had an implicit assumption about the geoid that's really different than, you know, people who are well informed about that. So I think that's just something to think about when evaluating these, is like, can it be extended in a way that can handle something where something comes along and you say, oh, this one has an additional piece of information that's sort of implicit in everything else, but this one has an explicit declaration and it's different. What do we do about merging that in when, you know, this one violates the assumption and says, oh, you can't always assume that anymore?
Okay, good point. And then Sky?
Yeah, so I think I'll probably build a little bit on what Tyler and Seth have just said and say the most important thing to focus on is the semantics, because all this structure stuff is just going to be variable and everything anyway. And I mean, really, maybe I'll be provocative and say that, like you sort of challenged us to say, maybe this isn't something we should even worry about, because, you know, many of these standards to describe the structure of data do fully exist, including going clear back to CSDGM metadata and into the attribute information and ISO 19115 feature catalogs and the way of describing the attributes and data sets in EML we've been looking at. They're all there and they give you a certain piece of the puzzle. But on almost every case, you're going to pre-flight your data anyway. You're going to validate what might be in the metadata and actually do introspection on the data, looking at a CSV and say, well, what's in here? And what are my range of values? And do I have any weird outliers? And, you know, just kind of basic things that you can do to check all of that. And, you know, if you feed CSV data through something like a Spark or, you know, Hadoop kind of pattern, you're going to do all of that stuff. It's going to build out what's called a Hive Metastore, and it's got all of that information in it, all the same structured stuff that we were just looking at, and in all of these different ways of looking at this stuff. But the important part is to say, well, okay, now that I've got this stuff, I have these characteristics of all of the columns in my data. What does that actually equate to, and what can I do with this stuff? Or what constraints do I need to have? Or what assumptions went behind this? So it's more of the deeper level meaning of things. So I would rather see us working as communities on like exposing that stuff, those registries of properties that we are using within our different systems in ways that lots of other systems can consult those registries and anything we add to them, annotations that we add to them about, oh, well, this, you know, I actually figured out that in order for this thing to work, I need to align with this specification of this particular attribute to work within my system, and expose that out to the rest of us so that we can compare notes. And then every time we get a bunch of weird data in a CSV, we can look at what our data looks like. We can go check the registry for what everybody else's data looks like that's like that, and see if we can get closer to understanding the actual semantics of the data that we're looking at and what we can do with them.
So if all of these methods are, you know, let's say roughly equivalent or roughly capable of describing the syntax, and the syntax is the easy part, but the semantics is the harder and more important part, do you feel that any one of these would be better suited for the semantic side of things?
I actually didn't, I mean, one thing I noted is I didn't see any case there where any of those specifications really laid out the domain of values and any place where you go to find something about that domain of values. References to controlled sources and other pieces there. There's place for it, and I think the CSVY structure that we were looking at had pieces of that, but most of them didn't even get to that point.
And I'm going to go ahead and recall people back into this main room from the other breakout. So just a heads up, they'll be joining in the next 60 seconds.
Okay,
So,
great.
Seth had his hand up, but I have.
I was just going to say what Tyler put in the chat, which is that Erdap has links to CF, so that's a plus on the semantic front.
So my comment on to what Sky said is, yes, most of those examples that you had did not reference dictionaries of measurement meaning for the most part, except in the case of things like CF. It's because those just don't exist. Very few of them exist. Darwin Core is one and CF is one, but there's not many others that are really rigorous.
And do we also need to be able to describe the, you know, the range of allowed values? Is that kind of what you're referring to also?
Maybe. Some specs have places to record that for an attribute, EML does.
Mm-hmm.
But that would depend. If you're talking about, say, water from one locale would have a different range of values than water from another. So that's kind of case dependent.
Got it. Okay, looks like everybody's coming back now, and we have, well, theoretically less than 1 minute officially left in the session. Maybe we can get a brief, you know, 30-second, 1 minute highlight on
and
each.
the room won't end automatically. So if you go a couple minutes over, I won't tell.
Okay, yeah. So if people do need to disconnect, go for it. But you know, we don't want to go too far over time. So Bridget, are you able to give us a very brief summary of key highlights from your group?
Sure. We talked about how the CSV on the web might be a little more flexible than the others across different types of disciplines. But the standard is, you know, it's 5 years old now, so perhaps it's time for it to be updated, which of course it's not out of our hands. We talked about how having separate files for the data and the metadata can be preferable in a lot of circumstances because it helps keep things cleaner, and a single metadata file can then be associated with multiple data files. But that perhaps if all of your data is in a cloud environment, it wouldn't be the best way to have things set up. And then at the end, before we got cut off, there was some talk about a possible extension of the standard that will basically work as an export for relational data, exporting into more of a flat file structure. So that was interesting. We were just getting into that before we got cut off.
Unmute. Thank you, Bridget, both for moderating and reporting. And yeah, it'd be nice to have a little more time to discuss some of these matters. Sorry that you got cut off. Let's see, Group B, focusing on datasets.xml. That was Nathan. Are you here and able to?
Yes and yes. Well, able to actually repeat what was said, not so much. But more or less what I heard in the meeting, in which I have tried to gather the notes, I'm not the best note taker in the world, is that Erdap and the dataset.xml file is a good, reasonable way of documenting the metadata that is associated with the files. And if the dataset.xml is used, it automatically gets used by Erdap, which can give a lot of benefits to being able to subset the files and look through the files themselves. I don't know if Bob or anybody else on that call would like to give a little bit more information
That sounds
than
good.
what I just get. All right.
I'm gonna, if I may, just actually ask a quick question of Bob. Is there one datasets.xml file that describe all of the datasets in your Erdap instance, or is there a separate one for each of the datasets?
That's correct. There's one file that contains a large number of chunks. Each chunk describes one data set, which in this case would probably be one file, but it could be a collection of files.
Okay. That was kind of the impression I got, but I wasn't sure. Group C was focusing on the CSV YAML, and Eric, I think you were in that one.
Yeah, I was. Hopefully you can all hear me. Yeah, our discussion just started getting heated as we jumped back into this session. But I think, high level report out from our group, which was relatively small, was that most of us did not know about CSVY. It was kind of a new thing, something we're kind of interested in learning more about. But that said, we all were quite familiar with CSV and YAML. And as a result, thought it was a pretty natural way to describe CSV files. We felt like there's probably quite a bit of tooling, tools and technology in different software languages and packages, things like that, to actually read the YAML files. So that felt good. We spent, I think, most of our session just asking questions about CSV and how it might be used. But I think, to a couple of the other questions we had, one advantage is having the metadata contained within the file. There's, some benefit to that. You can't lose the metadata, as it were. However, as some of the other sessions noted, there could be advantages also to not tainting your scientific data, your measurements, your CSV data when you change that metadata. So that's about where we got. We weren't quite up to the point of discussing other approaches, but overall, it seemed like a fairly natural fit, but it was something that we're not very familiar with.
Okay, great. Thank you, Eric. And I had volunteered myself to be the rapporteur for the Group D. None of the above other ideas. We spent some time talking about ecological metadata language, which is apparently another approach. I think it's XML based, but has some extensive use with, I guess, the ecological data community. I think Joe Porter mentioned that, and was seconded kind of by Margaret O'Brien. So I think we should look into that. I don't know much about it, and obviously we have atmospheric versus ecological data at NCAR, but so. Tyler pointed out we should just choose one and go with it. That sort of they're all good. Just make the choice and run with it. But making the choice is the hard part. That's why I wanted to have this session. Seth pointed out what happens when there may be implicit in assumptions in what we do and how the descriptions are, and we leave things out because we assume, oh, everybody realized that, and then suddenly a new user comes along and they don't realize, they do not make that implicit assumption. So we want things to be extendable, so you could kind of add later new information if you needed to make certain things more explicit. And then Sky was pointing out describing the structure is easy and in fact less important than describing the semantics, and we need a lot of work on that. I'm really describing the semantics of what these data mean and how we use them and so forth. So that's the end of the breakout. We are now 5 minutes over. I'm sure people need to disconnect and do other things. I'm going to linger around at least long enough to copy the chat into here if there's anything useful in there. And certainly if anybody wants to stay in and keep talking about this topic, that's great. Otherwise, we will thank you again for joining. Please put any feedback you have about the session in the schedule page. I think there's some way that you can give some pro or con feedback, smiley face or something like that. And I really thank all of you for joining and participating.